Okay. Let's start with the easy stuff first. Okay, now I need a hearing aid. What's the slope of number B or letter B? Anybody?
Negative 5/9.
5/9.
Negative 5/9. When you see y equals mx plus b format, the m is your slope. You don't even have to think. You're done. That is your slope. Negative 5/9. That was easy. Okay. Anybody want to guess at this one? What'd you get? Anybody?
Is it 3/7?
3/7. Anybody get a different answer?
-3 of that.
Now you're fudging. So we get negative 3/7, positive 3/7. Okay, I think it's that one. Okay.
Yeah, positive 3/7 too.
Yeah. How did you guys do it? I've seen some people make a table, which I find very difficult.
I kind of just moved it over there, then divided it. And I
Okay.
forgot the negative cancel.
Good. Okay. Not good that you did it. Good that you're aware of that. Okay. All right. So what he's saying, and what I hope most people did, is you take the 3x away from both sides, so you get negative 7y equals negative 3x plus 15. Okay. Divide everybody by negative 7. Okay, so you get y equals, the negatives cancel, so you have 3/7 x, okay, minus 15/7. So you just use your basic algebra skills to rewrite this problem. Since this is y equals mx plus b, okay, we know that the slope is 3/7, and that's it. Now, to me, that's the easy way. I've seen people do harder ways. They make a table of values and then they find the slope by some formula, but that's the best way. Over here, anybody want to take a shot?
0.
Okay.
Does not exist.
M equals 0. Does not exist. D and E. Well, it's one of those two, I'll tell you that. All right, let's see what we have. First thing is, you should notice there's no y value, so it's a weird problem. And so you should be thinking, uh-oh, Foster's trying to trick me. Okay, there's no y value in it, so it's a weird problem. Foster's trying to trick me. So we take 7 away from both sides, okay, and we end up with 4x equals negative 8. Divide by 4, and we get x is negative 2. Okay. Now, every year that I've ever taught this class, okay, and remember, I've been doing this for over 40 years in one form or another, okay, I say, what's the slope? And people tell me x equals negative 2. The equation said, find the slope. And people say x equals negative 2. What does x equal negative 2? What is that?
That's a line. It's a vertical line.
Okay,
So
that's its. Okay, keep going. I'm sorry.
Equation?
Yeah, that's the equation of the line. Okay, and you're right, it is vertical. That's the equation of the line. But I didn't ask for the equation of the line, not specifically. I asked for the slope. So when you graph this line, okay, when you graph this line, you get x equals negative 2, okay, which is right there. And because it's a vertical line, okay, it has no slope, or it does not exist. Whichever one you want to use. I don't know which one mom likes, but one of those two. Now, question, what if you get confused? You go, oh crap, is it 0 or is it does not exist? I can't remember. I can't remember. Well, look at this for a second. This point right here, this is -2, 5. Because on this line, x is -2. X is -2. So this is -2, 5. And this might be -2, 1. Okay. So if you use the slope formula, remember we have m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Remember that formula? So if we say this is 1 take away 5, y sub 2 minus y sub 1 over -2 take away -2, you're going to end up with -4 over 0, or maybe +4 over 0. It doesn't matter. The point is you have a 0 in the denominator for the slope. You're finding the slope because you made up 2 points randomly, okay, on this line. All we knew about this line is the x is -2, and we don't care about the y values. So you put those here, you do your math, you get a 0 in the denominator, and that in all of mathematics is never allowed. So that's where we either say there's no slope or it does not exist. Now, before I entertain questions here, do you have to go through all this crap? No. If you know that a vertical line has no slope, you can jump right to the answer. I'm happy with that. But what I'm trying to show you is, okay, what if you get confused? What if you get flustered on the test? How do you work around that? How do you help yourself? That's it. All right, questions about any of those, finding the slope of those? Okay. Then let's do 3 other problems. Can I erase this? Anybody gonna scream at me?
Hang on real quick, please.
No.
Okay. No, you're not gonna scream at me, or no, don't erase.
Okay, thank you.
Who else was yelling at me? Are we okay?
No, not yet, please.
Okay,
I'm done.
all right.
Thank
Okay. Anybody else? Am I okay? All right.
Yes.
Then a little bit harder. Okay. I want to find the equation of the line. Okay, now we're going to do 3 different ones. Part 1A, that passes through the points, what do I have? 4, 7, and 9, -3. That's one problem. A second problem, B, find the equation of the line that passes through, I'm going to give you time and let me leave it up here, but 10, -1, and is perpendicular to the line y equals -2/5 x plus 3. And somewhere over here, part C goes through 4,7 and is parallel to x equals 3. So 3 problems, find the equation of the line that passes through those 2 points. That's problem number 1. Problem number 2, find the equation of a line that goes to the point 10, -1 and is perpendicular to this line. And problem number 3 goes through that point there and is parallel to this line. So this should take a little bit more time. So I'm going to pause it. And okay, so here we go. When I taught finding the equation of a line, I said you needed a point, you needed a slope, and you needed an equation. Okay, always. There's no math teacher in the world that can ask this question without giving you this information. Now, we are allowed to hide it from you. Okay, but you have to have each one of these things to be able to answer this question. There's just no other way around it. Okay, again, we can hide it. We got points up the yin yang. Our point here, I'm going to arbitrarily use the point 4,7 because it's got positive numbers in it. But you could have just as easily used the 9, -3. We'll eventually get the same answer. But I'm going to use that because it's got only positives. I don't want to get screwed up with negatives, but that's just my personal bias. Now, the problem is where's the slope? Okay, the slope is missing. But it's hidden inside the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. The slope initially is hidden from you. But I gave you enough information that you can figure it out. So the slope is -3 minus 7 y sub 2 minus y sub 1 over 9 minus 4 x sub 2 minus x sub 1. So we get the slope is -10 over 5. So the slope is -2, or you could say -2 over 1, whichever we need. Okay, I'm going to call it -2 for now. Okay, so is everybody with me? Do you understand that we could have used either point? It doesn't matter. But you had to calculate the slope somehow. That was the slope. Are we okay?
Yes.
All right, now we plug it into the equation I said we need. So we take this, and the equation we'll always use, mx plus b. There are others, different books, different instructors teach this a little bit differently, but this is the way that about 90% of the world does it. Okay, so we plug in, what do we know? Do I know a y value? Yeah, 7 right there. M, -2, x, 4 plus b. So that's 7 equals -8 plus b. Okay, if I add 8 to both sides to get b alone, I get 15 equals b. And now I have everything I need, okay, to answer this problem. I put this and this together, and I have y equals -2x, because that's the slope, plus the 15. And that's the equation of the line that passes through those 2 points. Now, because I don't have a big enough whiteboard, I'm going to have to erase that in a second. Is that okay?
In a quick
Anybody?
second?
Well, I'll give you a chance to write it down, but I'm going to have to erase it so I have room for this. Okay, can I erase it? Can I erase my work here so I can do the second problem?
1 minute, please.
Okay.
So then the answer is y equals -2x plus 15.
Yes,
That's what they want.
right, because our equation is, well, yeah, I'm not gonna go into it, but yeah, that's
Got
it.
it. I
That's
get
your
it.
equation, okay?
Yeah, okay, thanks.
All right. Sometimes I talk too much. Go figure. Okay, can I erase? Anybody gonna yell at me?
Yes.
Yes,
Yes, yes, you're gonna yell at me, or yes, I'm gonna erase.
yes, you can erase.
You can
Okay.
erase.
By the way, I just saw in the news, they're opening up the municipal gym again tomorrow for vaccines. If you go like around 2:30 or so, or late in the afternoon when they're closing down, they may be able to give vaccines. No promises or whatever, but municipal gym in Balboa Park, behind the Oregon Pavilion, way down behind the Oregon Pavilion, where the Aerospace Museum used to be and all kinds of things. They say that they're going to have, I guess they call it a pop-up site. It's going to be there maybe tomorrow for sure, maybe the next day, they don't know. So anyways, it's a way to get your shot and not have to fight too many crowds. Okay, here we go. All right. Letter B. Find the equation of the line that goes through this and is perpendicular. Now, this is just like when we were doing before class. Do we have a point? Yeah, we got the point 10, -1. Do we have the slope? Yeah, actually, we do have the slope. It is +5/2. How did I know that? What in the problem told me what the slope was?
Opposite reciprocal.
Good. When it says perpendicular, it's the opposite reciprocal of this line. Opposite reciprocal. Okay, I'll break that up here. Opposite reciprocal.
That's only when perpendicular is in the
Yes,
equation. Okay.
yes, yeah. If it had said parallel, then we would use the same slope. Okay, but because it says perpendicular, then we have to use opposite reciprocal slope. So we pop everybody into our formula, y equals mx plus b. So our y value is -1. Our slope is 5/2 times 10 plus the b value. Okay, that's our formula. Plug everybody in. This -1 equals 25 plus b. You can do that on your calculator. 5/2 times 10, whatever, it becomes 25. Take away 25 from both sides, and we get -26 equals b. So put everybody back together, and we have y equals 5/2, 5/2x, the perpendicular slope, minus 26, the new y-intercept. And that would be the equation. That's the answer to satisfy problem B up here. Is that okay?
Yeah.
Okay, I'm going to try and leave that up so you can try and copy it or take pictures around my body as I'm moving in and out. I might have to erase it in a minute. Okay. So how about this one? through the 0.47 and parallel to x equals 3. Again, this is, the orange doesn't show up very well. This is no y value, no y. So it's a trick question. Something is weird there. When it's a trick question, you usually have to attack it in a non-normal way. Okay, so this is how I'm going to attack it. You might find a different way. I'm going to look at the graph. X equals 3 looks like that. That's the line x equals 3. Okay, I want to go through the 0.47, which is right there, more or less. And I want to be parallel to x equals 3. So I want that to be my line, that green one, because that green one is parallel to the black one. And the green one goes through 47. Now, what's special about the green line? Yes, it's vertical, but what's its equation that you can look at and tell in an instant what its equation is?
There's no Y.
Huh? No? Or there's no y, you're right. What's its equation, I guess I should say?
The X.
X equals
X-
4.
X equals 4, right. So the green one is x equals 4. Because in a vertical line, all of the x's are 4. In a vertical line, this vertical line, all of the x's were 3. So if you do a vertical line, all of the x's are the same. So, and I just got this answer by simply thinking about it. No real hardcore math was involved. Not like all these algebra steps, just thinking about it. So that's the answer. Okay, x equals 4 goes through that point and is parallel to the original black line. Yes or no? Anybody?
Yes.
Okay. All righty then. That was the warm up. Now I want to do a couple review problems. Okay. Make sure everybody's on track with chapter 5, systems of equations. So I need to erase here. Anybody still taking notes? Okay, here we go. All of those things that you guys have all been asking, all of these warm-up problems, were all chapter 4 stuff. And they would be good for exam number 1 and good for this Thursday's quiz. This next problem is from chapter 5. I want you to solve by substitution. Okay, this system, x minus y equals 6 and y equals x plus 6. That's problem number 1. And problem number 2, I want you to use elimination to solve this problem. 4x minus 3y equals 3 and 2x plus 5y equals negative 31. Is that right? God, I hope it is. 4x minus 3y equals 3, 2x plus 5y equals negative 31. So I'll pause while you guys work on that. I would caution you when I give the exam number 1, many times in the past, I've specified you must solve by substitution. You could use anything else you want to check your work. But the work I'm going to grade is showing you the substitution process. If this says, solve by elimination, then I'm going to grade your elimination work. Again, you can use anything you want to check it. If you wanted to do it a different way, cool. But I'm going to grade the elimination work because I want to see that you know that process. So take a few minutes. Okay, so the substitution technique was pick one equation, isolate one variable. It didn't matter which equation, eeny, meeny, miny, mo, this equation's got to go. That one, I like that one. Okay, it doesn't matter which one you pick, but get a variable alone. Well, the reason I'm picking that one is because the variable is already alone. Y is isolated. So that was step number one. Pick an equation, isolate a variable, and then plug it into the other equation. Plug it into the other equation. So we're saying here, we're saying that Y is the same as X plus 6. Okay. You say Y, I say X plus 6, we're saying the same thing. But we're going to plug it into this other equation. Now, so the other equation has X minus Y right there. But I know that Y is X plus 6. Okay, equals 6. And I just made a horrible mistake. A terrible mistake. There's something wrong up there on my whiteboard. I
There's
plugged.
no X.
Well, that's not a mistake.
It should be -6
Why?
because when you plug it in, it would be like -1 times X plus 6, right?
Yeah, because when we're plugging it in for Y, we're plugging in this entire quantity for Y. Y is worth all of that. So when you say X minus Y right here, you're saying X minus all of that. And that will totally change the intent of this problem if you don't distribute that minus sign. So if we do distribute, we have X, we have minus X minus 6 equals 6. X, distribute the minus sign in, so that becomes minus X and then minus 6 equals 6. Okay. Uh-oh.
Can I stop you for a second?
Yeah.
So you're taking which one of this problem one? Which equation first are you solving and then plugging into?
That equation has a variable alone. Y is alone. So I'm plugging into the top equation in place of Y. Okay. Look at the top equation. It says X minus Y equals 6. But in place of Y, I'm saying X minus X plus 6 equals 6. Because I'm putting that in place of Y. Because it tells me that is the same as Y. I'm substituting equals for equals. Okay, so X minus X drops out. I get -6 equals 6, and I got a problem here. The X's dropped out. There's no X's. Well, my first thought is, did I make a mistake? My first thought was, did I make a mistake? No, I didn't. Okay. So my next thought is that, well, what do I do? What does this what is this trying to tell me? Okay, it's some kind of answer. And what it's trying to tell me is this is impossible. So there is no solution. This problem, because that's an impossibility. -6 can't equal +6. And it doesn't matter what you do, even if you add 6 to both sides and you get 0 equals 12. I don't care. You can do it all day long. You're going to have an impossible condition right there. The number on the left will never equal the number on the right. Impossible. So you say no solution. Yes, no? Kind of okay?
Yeah.
It's a trick question, okay? It's a double trick question because you needed to distribute the negative sign. If you didn't, you still ended up with a trick question, but you got the wrong answer. Yeah. So you got caught a couple times. All right, so be careful. Now, elimination. One of the things I said for
Is that an
elimination,
x minus x or a y minus x? Sorry.
where are you?
Or on that problem you just did, it's like, it says x minus x plus 6
Right.
equals 6.
Yep. X minus X is no X's.
Okay.
X take away X, they're gone. There's no X's in the problem at all. All right. Number 2. The game was multiply one or both of the equations by some magic number. And you guys really fought me on the word magic number. Okay. The key was we want to add these two equations together so that one of the variables drops out. That means like we have a -6x and a +6x. When you add those, the x's drop out. Or let's say we have a 3y and a -3y. When you add those, the y's drop out. So our job is to somehow manipulate this problem so that the x's are the same number, but one's positive and one's negative, or the y's are the same number, but one's positive and one's negative. That's the real key. Manipulate the problem so that the x's are the same, but one's positive and negative, or the y's are the same, but one's positive and one's negative. There's at least 4 ways I can think of to do this problem, and they're all correct. Anybody want to guide me?
Yes.
What?
I did the bottom equation or I multiplied the bottom equation by -2.
Okay, and to me, that's the easiest, laziest way to do this problem. Because you don't have to mess with the top equation at all. So I would say something like, I personally will call that A and that B so we can talk about them. So we have equation A and equation B. Okay, and I'm going to leave equation A alone. I'm just going to leave it as 4x minus 3y equals 3. But I'm going to do what you said, -2 times equation B. And guys, this isn't just me writing it down for you, the student. This is what's expected of you as your work. This is showing your work, and tonight's lesson is really going to require this. You're telling the world, I took equation B and I multiplied it by -2. That's what that says.
So where'd you get the -2?
Because he ran through his times tables and saw that, who was that? Oh, never mind. Okay, and saw that if I multiply this by -2, then I'll have a +4x and a -4x.
And you don't need to do that same thing with the y's?
Well, no, because you're gonna make one thing drop out. So look what happens if we multiply this by -2. We have -4x minus 10y, because we're going 2 times 5 is 10. Okay, and this is positive, what's that, 62? I think that's right. Is that right? Yeah. Okay. How do I know I've done something right? Because when I add these two together, the x's will drop out of the problem. Okay. And again, your question is, where did it come from? And I said it was magic. You just run through your times tables very quickly. What could I multiply? What's the easiest thing to multiply one of these equations by so that the two variables would drop out? They would become opposites of each other. So here we go. Add these together. The x's drop out like they're supposed to, no x's. But I end up with -13y. -3y, take away 10y is -13y equals 65. Okay. No
Wait, why is
x's.
it equal 65? Why isn't it not 62?
I'm adding the two equations together. Where did I get the 13 from?
Oh, the 3. I'm stupid. Never mind.
Well, I won't go that far. You might be blind, but not stupid, you know. No, only I am stupid. You are not stupid. Okay. So divide both sides by -13. Okay, and I believe I end up with y is -5. Okay. However, you're not done. How come we're not done?
When you get
We need
X,
to isolate X.
X.
Yeah, you need to get x somehow. Okay, and getting x now is just an exercise in arithmetic. You just plug y back into one of your original equations. Doesn't matter which one, you just plug it back in and solve for x. I don't know which one I think I'm going to plug it into equation A because it has smaller numbers. I know that, again, that's just my idiosyncrasy. So I'm going to say 4x minus 3 times y, but y is -5, equals 3. So this is equation A right here. And I'm plugging the -5 in for the y value. So I have 4x plus 15 equals 3. Take away 15, -12, divide, x is -3. So I got y is -5, x is -3. The correct way to do this, I think Vince asked this last week, is the ordered pair -3, -5. This is my answer. Okay. Did anybody, I like multiplying by -2. To me, that's the easiest, laziest way to do this problem. And I'm big on lazy. But did anybody attack the problem differently? Everybody went after the -2 on the b value? Okay.
I guess.
Well, what if you multiplied equation A by 5 and equation B by 3? Wouldn't that make -15y and +15y?
Yeah.
So you could have made your y's drop out. It's really an open-ended process. As long as you make somebody drop out, it doesn't matter who, you'll get the right answer in the end. Okay,
Professor,
need-
quick question.
yeah,
I think last week on that same problem number 2, if it wasn't because of the -2, the way we solved it right now, we could
Yeah.
also make all the what you explained right now, right? The top equation and the bottom equation, make it the same to
Yeah.
cancel either X or Y, right?
yeah, it doesn't matter.
Use distribute to evenly, I mean, or
Right.
according.
Once you say, oh, look, I'm gonna get rid of my Y's and I'm gonna multiply it by 5, you multiply everybody in the top equation by 5. And then you're gonna multiply everybody in the bottom equation by 3. And that'll screw up everybody, but it'll make the two Y values the same. They'll cancel out.
Got it. It's a refresher. Thank you.
Okay, all right. Okay, we'll pick up some more of that, but that's chapter 5. What time is it? 38. Okay. So I have a relatively easy topic, and then I have an insanely ugly topic. Which one do you guys want first? We're gonna get them both tonight.
Ugly.
Ugly?
Is the ugly one the 3x3 equations?
Yes.
I had a feeling.
Ugly.
Yeah, I'd rather do ugly first while I'm still awake.
What? Are you telling me that math puts you to sleep? Come on now.
With the easy ones, first make it easier. That way,
No.
if they're really simple, or are they?
No, they have nothing to do with each other.
Oh,
They're totally different. Yeah, sorry about that. They're totally unrelated. Okay, we'll do ugly. We will do ugly. Did everybody get my announcement? Did you guys all see the announcement that went out today?
Yes.
No? Yeah.
No.
Whether, I don't know if you, I don't know if you had time to download that worksheet or not, but this is chapter 5.7. This is solving what's called a 3x3 system. And we use repeated elimination. Okay. So I'm going to break the steps up. These are the same steps that was on that worksheet, that handout. So if you handed them out, then, Jesus, come on, talk, Foster. Yeah. If you've printed it out or are going to print it, then you don't need to write these steps down. Okay, it might be a good thing, but that's totally up to you. Okay, here we go. First, you're going to label each equation with A or B or C. Okay. Secondly, pick any two equations and eliminate any variable. Now that's really open-ended. Okay,
It says
you've got
one-
three. Pardon me?
It says eliminate one variable. Does it matter?
Well, no, it doesn't matter. Eliminate any one variable. Okay, it doesn't matter. Okay. But the key is the third step. Using the unused equation, eliminate the same variable. Now, we've got to pause for a second. Okay. When you do step number 2, it will create a brand new equation that we will call D. If you do step number 2 properly, it will create a brand new equation D. And D, well, should be just 2 variables. If you do step 3 correctly, which I can't write 3 up there, and you do this, you're going to create a brand new equation we'll call E, and it will also have just 2 variables. And if we did everything right, these should be the same variables. If life is good.
Just a quick question. With the 3x3, can't you just use the methods that we used for the 2x2 and then just plug in your answers to the third and see if that's correct?
No, because you won't be able to eliminate. No, it won't work. You can't get.
What was the,
With 3 variables, you can't eliminate 2 of them. You can only eliminate 1 at a time.
Okay. Yeah.
I'm sorry, there was a question?
oh yeah, well, just from the sake of my notes, using step 3 does what?
Oh,
Creates a new variable, or I did that for 2.
and you do it for 3 also.
What does it do?
It creates a new equation. So this is step number 3, third, but it's really important that you do it right. So using the unused equation, okay, add the 2 together and eliminate a variable, but it's got to be the same variable that you eliminated before. And we call that new equation E. Okay. So we've created 2 brand new equations, D and E. And they should have exactly the same variables in them. Now I'm going to do a problem in a minute, but I'm going to have to erase this. So I hope you guys have this.
And then the second step creates a third variable.
No, no, we're getting rid of variables. We're starting with 3 variables, and then we're squeezing it down to 2 variables. And in a minute, we'll squeeze it down to 1.
Okay, so I have on here that steps 2 and 3 just create new equations.
That's correct.
Okay.
We're going to call D and E. Okay. We need to name them so we know what we're talking about. Now, fourth, okay, solve the 2x2 system with equation D and E. And again, I'm going to do all this. But you need to know these steps. And this is just like when I say solve the 2x2 system, we just did an equation up here a couple seconds ago, a 2x2 system. We just did that. Okay, it'll be exactly like that problem right there. And then fifth, I forget what it said, but what I'm going to say is fifth, back substitute, which I'll explain, to find values for other variables. And I will give you an example of that. And do I have a sixth on there? Something like an ordered triple?
Yes.
Yes.
Yeah. 6 ordered triple, which I'll explain in a minute. So I'm putting this up for those of you who didn't get to print it out, and now I'm going to have to erase it so I have room to do these. These problems take like a whole page to do. They're insane. Okay. Can I erase this?
Wait, 1 sec. I'm on the 6th.
Okay. It just says ordered triple, and I'm going to explain that, but
Thank you.
anybody else? All right, here we go.
Okay.
So x minus y plus z equals 2. Yeah, 2x minus y minus z equals -6. 2x plus 2y plus z equals -3. There's my system. Let me make sure I've copied it right. X minus y plus z equals 2. Yes. 2x minus y minus z equals -6. 2x, 2y plus z plus equals -3. Yeah. Okay. Notice something. This method requires all of your x's, y's, and z's to be on one side and in order. X, Y, Z, X, Y, Z, X, Y, Z, and out here to the side, those are constants. Those are just non-variable numbers. Okay, so a lot of times, a lot of problems in mom or wherever you go, they'll have, they'll have something crazy like 2x minus 3 equals y plus z. They'll do something just to screw you up. Well, you have to use your algebra skills to get 2x minus y minus z equals 3. So even if the problem is out of order to begin with, this process that we're learning says you got to put the numbers in order. X, Y, Z equals number. Okay, so this process requires that. All right, here we go. So first step was label these as A, B, C. Okay, A, B, C. Okay, that's kind of important, guys, because we're going to be able to talk about equation A. Okay, and everybody then knows what equation A is. If I say, let's take equation A and multiply it by 7, then everybody knows I'm going to take that equation, A, and multiply everybody by 7. Okay, it's really kind of important, and it's important that you put it on your paper. So that was step 1, label them as ABC. Step 2, pick any 2 equations and eliminate a variable. Any 2. Well, what if I took equation A and B and added them together right now, didn't do anything to them, didn't screw them up, didn't do anything, would a variable get eliminated?
Yes.
Who? The Z would. Okay, again, that seems easy to me, and I'm lazy, so I'm going to do that. So what you do is you write this down. You say, I'm going to take equation A, which is x minus y plus z equals 2. I'm going to take equation B, which is 2x minus y minus z equals -6. I'm going to add these two together and create an equation D. By adding these two together, I have a 3x minus 2y, my z's canceled out, equals -4. Okay, and that's my equation D. That's what I said. Step 2 was take any two equations. Okay, remember, you're lazy. Pick the two easiest ones. Any two equations, add them together so that a variable is eliminated. And call this new equation that we just created D. Okay, now the tricky part comes in step 3. I have to use the unused equation. Have to. And I must eliminate the same variable. So back up here, I have to use equation C because I haven't used it yet. And I must eliminate the Z. That's the game. I must use the unused equation, and I must eliminate the same variable I did before. So, looking at C, who could I add it with so that the Z would drop out?
Negative
B.
Z.
B? Yeah, does it have to be negative? Or aren't they already their opposites, so I don't have to do anything else to them?
Correct.
Yeah, so let's take equation C, okay, which is going to be 2x plus 2y plus z equals -3. And that was the unused equation, haven't used it yet. And equation B, which is 2x minus y minus z equals -6. Okay, if I add these together, I get a new equation called E, which is 4x plus y equals -9. Okay, now the game was these two, equation D and E, must have the same variables. If they don't, I've screwed up. So they have, this has x and y, this has x and y. They have to. If they don't, you did something wrong or you're going in circles or something. All right, let's pause for just a second. I went through the steps. I labeled my equations A, B, C. I picked any two and eliminated a variable. So I decided to pick A and B up here. And I noticed that if I just add them together without anything, any magic, I will eliminate the Z's. That's what I did. And I call this equation D. Then the real key is step 3, where you use the unused equation, C, and tell yourself I must eliminate the same variable I eliminated before. So I use C and B. They add together, the Z's drop out, and I'm left with those two equations. Okay, any questions so far? Okay, now D and E are 2x2 systems. They're two equations, two unknowns. Now I can solve them the way I've been doing all the homework. Okay. Does anybody see what could I multiply by if I was to add these two together? If you were to add these two together right now, would anybody be eliminated?
No.
I don't want to multiply E by 2.
I would agree with that. Multiply E by 2. Why? Because that would give you a 2y here, and you already have a negative 2y here. So you're kind of trying to take advantage of what the problem gives you. So I would totally agree. I would do something like this. I would say 2e. Again, I'm telling everybody what I'm doing. That's what 2e means. I'm taking equation E and I'm going to multiply it by 2. So that's going to give me 8x plus 2y equals negative 18. And I'm going to take D and leave it alone. So that's going to be 3x minus 2y equals negative 4. If I add these together, I get 11x. My y's drop out. I get negative 22. Divide both sides by 11. I get x is negative 2. Now, we're not done by a long shot, but that's the majority of the work. And so I think step number 4, I said, solve the system, the 2x2 system with D and E. Well, that's what this work was. I decided to multiply E by 2, or somebody help me. Multiply E by 2. That made my y's want to drop out. Yay, I'm happy.
Question, sir.
Yeah.
What did you mean they had to be the same? You said if you did everything, D and E would be the same, or maybe I just misheard.
We'll have the same variables, not wouldn't be the
Gotcha.
same equations, but this is equation D, we say is an equation in X and Y, meaning their variables are X and Y. Equation E is an equation in X and Y. So they will have the same variables.
Gotcha.
Okay. Good clarification.
Real
Anybody else?
quick,
Yeah.
guess I'm confused that the 3x minus 2y. Oh, you plugged in D. Sorry.
Yeah, I just took D and E. Let's get some color pins. I just took D and E and figured out, okay, who can I eliminate? All right, so we okay, everybody? So well, how come I know I'm not done?
Because now plug it into the other equations
Right, now this.
and find Y and Z.
Y and Z, good. So look what we started with. We started with 3 by 3. And then we squeezed it into a 2 by 2. And now solving that 2 by 2, we got an answer. X is negative 2. That's kind of the process. We took the 3 by 3 system and using steps 2 and 3, we squeezed it into two 2 by 2s. And then solving that, we squeeze it into an answer. Well, now what we're going to do is very slowly and very carefully substitute backwards. You can't jump all the way back up here. So you're going to take your x equals negative 2, and you're going to plug it into one of the 2 by 2s. So x equals negative 2. You're going to either plug it into D or E, it doesn't matter. You got X, you're going to go back into one of the 2 by 2s. Which one do you guys think is easier? D, plug it into D, or plug it into E? E? E. Okay, E. Fine, good. So I'm gonna take this, and I'm gonna take equation E, plug this X in, so I have 4 times -2 plus Y equals -9. It gives me -8 plus Y equals -9. Add Y, add 8, I'm sorry, add 8. And I get Y is -1. So there's an answer. Well, okay, let's pay attention to what I did. I got X is -2. I plugged it into one of the 2x2 systems. I'm working my way back up to the top. But now I have 2 answers. I have X is -1 and I have Y, I mean, X is -2 and Y is -1. So what am I going to do? I'm going to take both of those and plug them back into one of the 3x3s. Okay, and it doesn't matter which one. Again, you pick the 3x3 that seems easiest. That one is the one that jumps out at me. Okay, but it doesn't matter. So you're going to take X is -2. We plug it in here, figure out what Y was. Now we can take both of those and plug it into one of the 3x3s to figure out our Z. So I'm going to come over here and kind of work. You'll see my best side. I'll get out of the way in a minute.
When you said plug -X or -2 for X into one of the 2x2s, you just
Yes.
meant pick one of 2
Pick
problems.
one of the 2, whichever. You're going to plug -2 for X. Do you want to plug it in this problem? Or do you want to plug it in this problem?
Oh, I see, into the newly made equations.
That's correct.
I got you.
Okay. So I'm going to take equation A and get X.
Yeah, I was kind of confused. So instead of saying the 2x2, can you just refer them as D and E?
Yeah. Okay. So D and E, would you rather put that there? D and E?
Yeah, that makes more sense.
Okay. Okay. And then this, instead of the 3x3s, you're going to A, B, or C. Sure. I can understand that. So -2 minus Y minus a minus plus a Z equals 2. Notice my use of parentheses. So I have -1 plus Z equals 2. Because again, we're back to minus is plus. So -2 plus 1 is -1. Add 1 to both sides, we get Z is 3.
Which equation did you plug it into? D or E?
A.
Oh, wait. No. The one that you have to plug into the newly made equations. Oh, E, I got you.
Yeah. Now that was just my personal preference. I plugged it into E. You could have plugged it into D and you're still going to get the same answer.
So after we find X,
Yeah.
before we can find Y and Z, we have to deal with the D and E equations now, right?
Right.
Okay.
So you plug X into D and E, that gave us a Y answer. Excuse me, I should have said we plug X into D or E.
Okay, you can plug it in either equation.
That's correct. That's correct.
And that's pretty much just to check your work because it equals the same as the other X.
No, this is to find the other variables. It is checking your work also, But this is, because when you're here, remember, you're only 1/3 of the way done. You've got to get you got to figure out an X and a Y and a Z.
Yeah, I plugged in the -2 in for X on the problem E, and then it gave me the -1 for Y, and then I plugged that into E, and it gave me -2 for X.
Right, but that, no, okay, you're going in circles. Once you get -1 for Y, I guess you're right. I see what you're saying. It's a check, but you don't actually need to do that. Once you get Y is -1, then you pop everybody back into A or B or C, and that'll get you your Z answer. So then the third step, the sixth step, I'm sorry, was your solution is called an ordered, hang on a second, ordered triple. Okay, and an ordered triple is an X, Y, Z. It always goes in that order, X, Y, Z. So your X number is first, so it's -2. Your Y number is second, -1. Your Z number is a 3. So that would be your answer. That's called an ordered triple. It's like an ordered pair, but an ordered pair has 2 numbers. This has 3. And it actually has meaning in 3-dimensional geometry, which I'm not going to get to tonight. It really does make sense.
This really is.
Is this gonna be on the exam?
Oh, God, yes. Oh, yes. This is going to be on the exam.
And we have to solve for all of these.
Yes. Yep.
Yeah, that really was ugly.
I told you. We'll do one more.
Okay.
Tell me we have to do one like the word problem and the 3x3 homework.
Is there a word problem in the 3x3?
Yeah, it has like a bunch of like percentages and whatnot to add even more to this.
Oh, I should have deleted that one. I tried to delete all word problems.
Please do it then.
Do
Okay.
it.
It will be strictly an algebra problem like this. It won't be a word problem.
Oh,
Okay.
good. That one was rough. Took me like
Yeah.
an hour.
An hour? Really? Okay.
I'm not as smart as you.
No, you're probably smarter. Okay. So let's try one more, and then we'll go to the easy stuff, and then we'll see what we have. All right, I need to erase. So here we go.
Not yet.
Not yet? All right.
And then so finally, once you have your X and your Y, you just plug those into all the variables for A, B, and C equations.
Well, you pick A, B, or C,
I'm doing
but
C.
yes,
Oh, just one of them.
just one of them.
Got you.
You're making way too much work. Just pick one of them. Just like here, we picked D or E. It didn't matter which one. Just pick one of them. Okay, so we pick A or B or C. Okay, I'm going to erase the system. I'll leave my work up here, but I'm going to erase the system. Is that okay with everybody? Okay. Nobody's
Good,
yelling at
thank
me.
you.
Nobody's yelling at me. All right. Okay, here we go. First equation, 3x plus y minus z equals 2. 2x minus 3y minus 2z equals 1. And 4x minus y minus 3z equals 0. Okay, let me read it back and make sure I got it right. 3x plus y minus z equals 2. 2x minus 3y minus 2z equals 1. And 4x minus y minus 3z equals 0. Okay, I want to guide you a little bit, and then I'm going to stop and let you guys work a little bit and get all confused, and then we'll clean it up. Okay, label A, B, C. That's easy. Pick any two equations and eliminate a variable. Well, think lazy. Which two equations, if I call these A, B, and C, A, B, C, which two equations can I pick that will easily eliminate a variable?
A and
A
C.
and C.
A and C, and they will eliminate the Y. You guys agree with that?
Yeah.
Okay, that's how we're going to start. So now I'll put it on pause and you guys see what happens. And that means the video of this is going to be pretty crappy. Okay, for the sake of time, so we get out of here at a reasonable time, I took equation A and C, I kind of guided you, I rewrote them here. Okay, I rewrote them here and added them together, created equation D, and I have a new equation with X's and Z's and the Y's dropped out. Okay, now I'm going to take, okay, I have to use, this is the tricky part, this is the hard part in my opinion. I have to use equation B, have to. And I have to eliminate the Y. That third step is the critical step in everything. I have to use equation B, and I have to eliminate the Y. So which one of these, A or C, could I use to help me eliminate the Y with B?
C.
See?
B and A.
Okay, what would you do with A?
You would,
I multiplied it.
Multiply by 3.
You got it. You got it. I like that. So we're going to take equation B. And I have 2x minus 3y minus 2z equals 1. Okay. And I heard everybody say, now remember, I want to get rid of the y. Okay. So if I did 3 times this y, they would cancel out. So that's 3 times equation A. So I have 9x plus 3y minus 3z equals 6. Did I do that one right? 3 times A, 9, 3, negative 3, 6. Okay, cool. If I add these together, this is where I've created my equation E.
wait, are you using A or are you using B?
B, I have to use B, and I have to use one of the other ones because you always have to have 2 equations.
Okay, so I guess I'm on the step 3 times the equation B, so you would just distribute.
No, you don't want to do 3 times equation B. You want to leave B alone.
But you need to get rid of the Y.
So we did 3 times equation A, so that one will be a minus 3 and the other will be a plus 3.
Oh, so we're using a different equation?
You have to, yeah. That's what I did the last time also.
So
You
we're not
have-
using D yet. We're just using the original still.
Yep.
Okay.
Yep, you use the originals to create D. You use the originals to create E.
Is it
Then-
okay? Is it okay if we used a different equation than the ones that you're putting up there? Are we gonna still get the same
Oh, God,
answer?
yes. Oh, yes. What would you
The
use?
problem when I do that though is that I don't understand anything you're doing. So it makes way more sense if I do exactly what you're doing, like using the same variables and problems.
Well, that's fine, but somebody else asked, could they do it differently? And the answer is, yeah, they could.
Oh yeah, I was just talking to you, I guess.
Okay. So I have equation B, and I have 3 times equation A. And now I can see that if I add these two together, the y's will drop out. So I have 11x. My y's drop out, minus 5z equals 7. So my check is my equation D and my equation E, do they have the same variables in them?
Yes.
Yes, so I know I'm on the right track.
And you distributed the 3 into 3x and y and the z.
Yes, for equation A, yes. Okay, now what do I do? I don't see, there's no nice way of doing this one. Ouch, ouch, ouch. Somebody please. Okay. I think instead of getting fancy at this point, I think I do 11 times D and get 77x, and negative 7 times E and get negative 77x. Okay.
Could we do the Z instead of the X's to get those same variables and do like negative the 20? So multiply -4 by 5 and then the -5 on equation E by 4 to get that the same?
Okay, yes, you can, and that's perfect. I was afraid of doing that and screwing students up with the negatives. What about everybody? How do you feel? Do you want to go 11 times D and 7 times E? That gets big numbers, but it doesn't matter. Or do you want to go 5 times D and get 20 and 4 times E and get 20? Anybody have a feeling?
Yeah, I did it with 20.
I use negative as well.
Okay, I think I heard enough people say you got rid of the Z's.
I have a question.
Yeah.
Regardless of which variable you try to get rid of, wouldn't you have to use a negative for both
Yes.
trying to get rid of x and z? Okay.
Yes, you would. Yeah. Okay, so, all right, here, let's get rid of the Z's. Okay, I want to get rid of the Z's here and here. So I'm going to do 5 times equation D. So we take equation D, multiply it by 5. So I have 35x minus 20z equals 10. 5 times equation D. 5 times 7, 5 times -4, 5 times 2. Now I have negative 20z. I've got to turn that into a positive 20. So I'm going to go -4 times equation E. So that's going to give me -44x, -4 times 11, 4 times 5, positive 20z, and -4 times 7 is -28. Okay, negative 28. So if I add these two together, I get, oh God, what's that? 7 and 4 is 11x. Is that right? No. 9x? 9x. Is that right? 9x. Negative 9x? Maybe I need a calculator. Maybe I'm falling asleep. Negative 9x. Is that right? Yeah.
Yes.
Equals 18 negative. Is that right? Yes. So x is negative 2 again. Okay. So now I'm going.
Is it a positive too?
Oh, thank you. It's positive 2. Whoa, that would have just screwed up everything. Positive 2. Thank you, thank you, thank you. Oh boy, that would have been really bad. Okay, now where do I plug x? I got x is 2. Yay for 2. What do I do with it?
Plug it into one of the original equations, A, B, or C.
No.
No.
Or D or E.
D or E.
D or E. Think about this for a second. If you took x and plugged it in here, you'd still have 2 unknowns. Okay, it wouldn't help you. But if you took x and plugged it in here, then you could solve for z. You'd only have 1 unknown. So that's why we take x, we've got to plug it into D or E. I don't see an advantage. Okay, I'm going to plug it into E. I don't know, because there's room here, I guess. So 11 times 2 minus 5z equals 7. So taking x, I'm going to plug it into E. So that's 22 minus 5z equals 7. If I take 22 away, I get negative 5z equals negative 15. Is that right? 22 take away 7 is 15. So divide, I get z is 3. So now I have x and z. So now I can plug it into A, B, or C. Take your pick. Oh, which one? I don't see an advantage.
Professor, so I did
Well, we got a echo somewhere. Try it again. Okay, I did a what? Somebody started talking. I didn't see who it was, but we had like a double, triple echo. It's like you got 2 of your speakers on. Okay, anyway, then I'm going to go back, and just because I'm totally unimaginative, I'm going to take all of these and plug them into A. I'll get out of the way in a minute. So A says 3 times.
Can I stop you
X.
for a second?
Yeah.
So I still was back on, how did you drop out the y for equation A with multiplying it by a 3? Because it just gave me a negative 3z or a positive 3y. And then the equation B or D doesn't even have a y.
It's not supposed to. Wait a minute.
Yeah, but when I multiplied 3 by equation A, I didn't drop the y out.
Did you add it with equation B?
I added C, equation A
No.
and C.
No.
And then I got D. And then I took A times 3. And then I was going to plug and then add D to that.
No, add B to that.
B.
You have to add the unused equation, not the new equation, the unused equation. Okay, so I'm going to finish this thing off. So 3 times 2 is that plus y, we didn't get y yet, minus z, so minus 3, oops, equals 2. Okay, I'm bouncing all over the place. 3 times 2 is x. We don't know what y is, so plus y, minus 3 z equals 2. So I have 6 plus y minus 3 equals 2. 6 taken by 3 is 3 plus y is 2. So I get y is negative 1. So I get solutions triple 2, negative 1, 3. Okay, that would be my ordered pair answer.
And just to confirm, if you use any other equation, you'll get the same answers that you are getting right there, right?
Absolutely.
Okay, thank you.
Absolutely. You have to. I mean, that's why it's going to be so important that you guys show me all your steps organized with the letters A, B, and C and all that kind of stuff, because it's entirely possible that with 30 something students taking a test, okay, there's how many permutations? There's about 16 different permutations, 16 different ways that people can solve this and still all get the same answer. And I do look at your work. I really, really do.
And
Okay,
then,
so, yeah,
so the new equations, I see the 5b and the negative 4e. You would want what we multiply the equation in front of it like that?
yeah. Because that tells me what you're thinking. And
Okay.
then I can follow your work. See, I do follow your work. And if you make a mistake, I still will follow your work. And then I'll judge how bad was your mistake. If it was just a dumb arithmetic mistake, okay, I won't take off points, as many points. But if it was a critical logical mistake, then I'll take off more points. And these things help me get in your head. They help me to understand what you're doing so I can determine, do I take off a lot of points or do I take off no points?
Okay, that makes sense. Thank you.
Okay. Yeah, we're running out of time. I wanted to show you something on the calculator, but I'm not gonna. Okay. We'll come back, pick these up a little bit tomorrow night, over the next couple of nights. I want to get into that with the so-called easy thing that I was talking about, and that's it. So bear with me. We're gonna go. We've gotten out early a lot of nights. Tonight's not gonna quite be an early one. We'll still be done by 9, I promise that, no matter what. So I got to erase this. So take a screenshot real quick. I got to erase. Okay, here I go. I'm waiting for the yell. Okay, this is chapter, where to go? 5.6. Chapter 5.6. This is called a system of inequalities. And the only way we can do this is by graphing. There's no algebra to it. Well, I mean, it is all algebra. All of this stuff is algebra, but there's none of this, 3A, 2B, add them together crap. It's just graphing. So let's go back to a real quick review. Okay, back in chapter 4, which is going to be on our Thursday quiz, we would graph this. I could say graph 2x minus y greater than, I don't know, 4, something like that. Now, we had all kinds of discussion. What's the best way to graph this? Okay, and I don't care how you graph it. Some of you built tables. Okay, some of you put it as a slope intercept. It doesn't matter to me as long as you get it graphed. So I'm going to graph it very quickly. We're going to pretend that this is 2x minus y equals 4. We're going to pretend it's an equal sign. Okay, I personally am going to build a table. Okay, if x is 0, then I get 0 minus y equals 4. Multiply both sides, I get y is negative 4. Okay, that's the y value. If y is 0, then I get 2x minus 0 equals 4. That's 2x equals 4. That's x equals 2. Again, look, I'm building a table. If you want to use slope intercept, go right ahead. If you want to use different numbers than I use, go right ahead. The end result is we're going to get the same answer. So then we graph this. Okay, so we go to 0, negative 4. And we go to 2, 0. Now is where the thinking comes in. Okay, so we took this problem. It says graph this. We pretended it was an equal sign. We got our points. We're going to draw lines. First question to everyone. Do I draw a solid line or a dotted line?
Got it.
Got it.
Because it's greater than not equal. Okay, so I do a dotted line. Bing, 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 bing. Bing, 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 bing. So there's the line. Okay, next, really important, basic fundamental concept. Because it says graph an inequality, that says we have to shade. That's what you're picking up on as the student. When you're graphing an inequality, that tells you we need to shade. And so our choice is, do we shade up or do we shade down? And we talked about all kinds of trick ways of doing it. The safe way is what we called a test point. The safe way was to create a test point, and the test point usually was 0, 0 for our test point, but it could be any point that is not actually on the line. So if we test 0, 0, we plug it in here, we get 2 times 0 minus 0. Actually, we plug it in here. Is it greater than 4? So do some arithmetic. This becomes 0 is greater than 4. That is false. So my test point, okay, was false. That means everything above the line is false. So I needed to shade below the line, and I'm done. Okay, that was it. That's a review from chapter 4, where we graphed an inequality. We pretend it's an equality and graph the line. Whether you like slope intercept or a table, doesn't matter to me. You graph the line. You had to remember whether it was a dotted line or a solid line. And then you had to figure out somehow, some way, where you shade. Notice something. The original problem was greater than, but we shaded below. Okay, so that test point is important. You can't always assume greater than means above. Test point will always give you the right answer. All right, that's review. Now I got to erase. Any questions before I erase and show you the new stuff? Because that was chapter 4. Okay, then chapter 5. What if I gave you this? Chapter 5. What if I said system y less than or equal to 3x plus 2 and x plus y greater than -1? What if I gave you 2 equations that were both inequalities? Okay, well, guess what? You graph them both on the same grid. Okay, so we're going to pretend that we have y equals 3x plus 2. Take the top equation, the top problem rather, and pretend it's an equal sign. Now, the fastest way to graph this one is not with a table of values, but to say my y-intercept is 0, 2, and to say my slope is 3/1. Okay, so hang on. Okay, so 0, 2 is here. And we're going to go up 3, 1, 2, 3/1. Okay, now I'll get out of the way. So went off to the side. I got my y-intercept was 0, 2. Then I used rise over run up 3, 1, 2, 3/1. And I can see the line. Question is this a solid line or a dotted line?
Solid.
Solid, because it's an equal. So it's solid. Okay. Now, this is where I differ from the text. Okay. I'm not going to shade, but I'm going to make a note to myself. Where do I shade? Okay. Does anybody remember the shortcut? If it's in slope intercept form, how can I tell where to shade? Do you remember that or not?
That's where the arrow's facing, right?
Yeah, basically. But you can only use that shortcut if your equation is in slope intercept form. So this is saying y is less than, y is smaller than this line. Okay, so I'm going to shade below, but I'm not going to actually shade that way yet. You'll see why in a moment. I just made a note to myself, I'm going to shade below. You could have picked a test point also and figured out that you're supposed to shade below. I don't care how you figure it out, but you're going to shade below. Now we go to the other line where we pretend it's x plus y equals -1. All right, this one I'm going to use a table. X, plug it in, y. Trust me, I've got my eye on the clock. Okay, I'm trying to speed up a little bit to get us through, but if x is 0, y is -1. And if y is 0, x is -1. Okay, trust me, I've never made a mistake. So I have 0, -1, which is right here. And -1, 0, which is right here, more or less. This is a dotted line. Okay. So the second one, I graphed it over here. It's a dotted line because of this, greater than, but not equal. Question, where do I shade on this one? Well, let's pick a test point. Let's test 0, 0. Okay, so I have is 0 plus 0 greater than -1. That's what my test point says. 0 plus 0 greater than -1. So 0 greater than -1. True. Okay, now wait, where was the test point? Where was 0, 0 relative to the green line? It was above. Can you guys see that? 0, 0 is right there. It was true, so everything up here is true. So I'm going to shade above. Okay, we will go over this tomorrow, but now watch carefully. Okay, we want to shade below the black line and above the green line. We want to shade below the black line because we did our interval testing and above the green line. So where would that be? Well, below the black and above the green would be in this region here. That's the only region. So your answer is shading. I apologize for going through that fast. Oh. Hang on one second. I need to show you something. I want to do something really cool. Okay. Close this, close this. Okay. Hang on. Up here, I have something called, I think I've talked about this before. This is called Desmos.com. Desmos, DESMOS.com. Okay. I believe you can get to it on your phones, your tablets, all your computers. Desmos.com. So it does a lot of things. Okay, but I'm going to show you the graphing calculator right here. You hit the graphing calculator, it starts up. What was our first equation? Y less than 3x plus 2. So I'm going to type y. Now to get less than equal, I literally type the less than symbol and I hit the equal symbol and it automatically knows what I'm doing. Less than equal 3x plus 2. Boom. There's our line. Okay. And there's the shading below that line. There it is right there. And notice it's a solid line. Okay. Now we want to go to equation number 2, which was x plus y. What was it? Is greater than -1. Greater than -1. There's that line. And notice you can see here it's dotted. Okay, just like we did. And where are both colors simultaneously, where it got darker? Right in there. And that's the same area that we did. If you're not sure, you can come back over here and you can turn off, right? Clicking on this thing, you'll turn off that graph for just a second. So you see, oh, there's the second graph. Okay, and turn it back on, turn that off. Oh, there's the first graph. So Desmos.com will allow you to graph anything. By the way, y equals x exponent squared minus 2x. Okay, there's a parabola. We'll be doing those. It will graph literally everything. It's an amazing tool. Desmos.com. I urge you to try it. And with that, okay, I'm done for the night. I'll try and finish a little bit earlier tomorrow night for all of us. See you guys later. Edward, don't leave if you're there. Edward, do not leave. Okay, new share. Advanced. Oh, I don't want to run that. Switch camera, switch camera, switch camera. Where'd it go? Oh, there I am.
Thank you. Have a good night.
All right, see you later.
Thank you.
Good night.
Somebody asked a question and I kind of want to know the answer before I leave.
Okay,
It says, false is below and true is above for the shading. Is that true?
on this particular problem, yeah. False is just, that changes on every single problem. Okay,
Depending on the sign. Is that?
wait a minute. Say again.
So the question is, so we're talking about true or false and the shading basically, right?
Right,
Oh, it looks like Anne answered it.
what'd you say?
Anne said with that, false is to shade the opposite side of the test point. True is the same, true is the same side of the test point.
Right. So I got true. True, the test point was 0, 0. So I shade on the same side, I shade towards truth. Okay, so my green line should have been here shading towards the test point. Okay or not?
So if it was false, you would have shaded under.
Under it, right.
I
You
got it.
can't, your test point it's a wonderful tool because you can't go wrong. You shade where truth goes. So truth is relative to the line. If above was true, you shade up. If above was false, you shade down. But it's going to be different on every single line. I like what did Anne say? I liked how she said that. I don't see it. She said something. Oh well. Did I answer that or did I make it more confusing?
You answered it. For
Okay.
me, you did. Yeah.
Okay. Anybody else? No? All right. Anybody have any other questions?
I have a question about homework.
Sure.
Can you show the homework for chapter 4? Because when I go on Mom, I can't see exactly the homework for chapter 4. I want